Regression coefficients for dummy variables. Suppose we want to know if listing on an index will impact the stock's return. And I just want to pause there for a quick second. In this case, the stock is either listed or not listed on the index. In other words, there's no numeric value. It's not like we're regressing against sales, where the dollar value for sales can be any figure. In this case, the stock is either listed or is not listed on the index. Now, this is why we refer to it as a dummy variable. So again, there isn't a numeric value. It's just you either are or you are not in accordance with that underlying dummy variable. So to see if being listed on the index will have an impact on return, the analyst gathers the following information. First, she measures the average return of stocks listed on the index, and she notes that on average, that group yields 12% return. And then she compares that with the average return for stocks that are not listed on the index, and she notes that that group is yielding 10%. So if I can use a real-life example, the S&P 500, which is probably most popular index. So let's just assume that the return on the stocks listed on the S&P 500 returned 12%. Whereas the stocks that were not on the S&P 500 index yielded 10%. So therefore, the average difference is 2%. Consequently, the regression may be expressed as follows. So using our generic regression framework, how do we tweak that for the situation that we're looking at? Well, the dependent variable here is stock return, because we want to know if stock return is dependent upon whether the stock itself is listed on the index or not. So we start off with the constant, which is 10%. That's this 10% right there. Now, if the stock is listed on the index variable or the dummy variable will register a value of 1, and therefore 1 times 2 is 2. So how do you read that in English? Work backwards. If the stock is listed on the index, it yields an extra 2% return, and therefore we expect the return to be a total of 12%. So ladies and gentlemen, do you see how I'm just taking this narrative and just arranging it as a regression equation? That's all it is. So basically, this 10% is a constant, and the dummy variable yields you an extra 2%. So if you're on the index, you get an extra 2%. If you're not on the index, you don't get an extra 2%, and you're stuck with 10%. That's all there is to it. That's all there is to it. So what do we do if we come across a stock that's not listed on the index? Well, if it's not on the index, the dummy variable registers a value of 0, so this whole thing disappears, and therefore we expect an average return of 10%, which is what our sample observation told us in the first place. And there it is. If the stock is not on the index, the dummy variable index is equal to 0. Stock return is 10, and therefore that would be the value for the constant itself. And then naturally, B0 represents the average return of stocks that are not on the index. And as I said before, if the stock is in the index, the dummy variable index registers a value of 1. And therefore, the average return would be 12%. So therefore, B1 represents the average difference between index stocks and non-index stocks. So you got to be careful there. This 2% is not saying that stocks listed on the index will make 2%. No, it's saying stocks listed on the index will make an extra 2% relative to the stocks not listed on the index. Note 3, since the coefficients, i.e. the B0 and beta 1, were estimated using samples, it's possible that after factoring for some sample error, the population coefficient for beta 1 is insignificant. In other words, so this 2 here, so anything calculated from the sample observations is subject to errors. Because what if you pick the wrong sample? What if your sample is not representative of the true underlying population? So what the author is saying is the following. It's saying, look, I get it. You got these values from the sample, and it seems as if a stock is listed on the index, you'll make an extra 2%. But what if your sample was wrong? So after factoring in that margin of error, is it possible that this beta 1 term is equal to 0? Well, what does that mean? It means, is it possible that it doesn't make a difference whether you're listed on an index or not listed on the index? So ladies and gentlemen, do you see how the quantitative analysis must be accompanied by common sense understanding of what's happening? There it is. Is it possible that there is no significant difference in returns between index stocks and non-index stocks? So the rule of thumb is the following. So this is our T-stat, and T-stat measures how far the coefficient deviates from 0 measured in units of standard error. And the rule of thumb is as follows. If the T-stat is less than 2 standard deviations away from the null being 0, then we would have to accept the null. Because what we're really saying is, if you think about it, we're saying that B1 is really not that far away from 0. So therefore, we accept the null. And the null, of course, is that it's insignificant. On the other hand, if this coefficient is more than 2 standard errors away from 0, well, that's very far from 0. So therefore, we would reject the null and therefore accept the alternative, meaning that the beta 1 is significant. In other words, the true population beta 1, even after you account for errors, is still far different from 0. So when you reject the null, we accept the alternative that it is significant. Now, how confident would you be in this statement? Because here's where this is coming from. We still don't know what the population value is for beta 1. In other words, we have no idea what the true figure is for how much extra return index-based stocks make relative to non-index-based stocks. All we got to go on are these sample findings. So when you make these conclusions, i.e. that beta is significant or beta is insignificant, without actually knowing what the true population value is, you have to indicate how confident you are in your statement. So basically we're saying, look, there's still some uncertainty, but I am 95% confident in these conclusions.